If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay students, let's welcome in the lecture 28 of this series. So here in the third step, DC protection, up to now we have seen second step, first step, second step. First step was 80 to 90, second step was 100 plus 50, that is 150% original line plus 50% of the next line, and it is full backup for the desired line as well as 120% of the next longest line. That means you see here longest line, earlier was shortest line. You take care of all these points. It is 120% of the next adjacent longest line, means it will take 100% of the original line plus 120%. So some layman sense you can say 220%, but it is not exactly 220 because 100% of the original line and 120% of the next line. So it is not that 220% of the original line. It will depend what is the length. Okay, the idea is that if there is an worst case under each of the distance relay, it is very much worst case, we are taking extreme worst case condition, then also my relay it should be able to protect the desired line. That is the main idea. If in everything comes below, then also how much below it will be? 200%, it will reduce to 100%. Then also I have, because I have up to 220% I have given third step one. So if it is reducing by half also 110%, still my 100% line is protected. So that is the idea. So what should be the operating time of step 3? Operating time, because it will wait for step 2 then STI, because some area again there is a common area, so it will wait for first step 1 will do. If it is not doing, then step 2 will take care of T1 time. If it is not taking care of, then step 3 will come. So there is an intentional time delay we have given. Now in addition to of this first, second, third step relays, we have additional distance measuring unit that is known as fault detector or inceptor. What is the use of this? We will see. A fault detector is an instantaneous in nature. There is no intentional time delay. If it senses there is a fault, then it will automatically close its contact. And the reach is typically desired line and 150% of the longest line. Now it is the extreme case. It is 250% now. 100% of the original line plus 150% of the next longest line. So it up to 250% it can sense if there is any fault or not. So first one is 80 to 90, second one is 150, you can say 150 of the shortest, third one is 100, then 120 of the longest, and this one is 100 and 150 of the longest. So how all these relays are connected? Now you can see here, if you can see this figure, then everything will be getting cleared. So let me draw a feeder first so that you can understand. Suppose this is, I'm drawing it little bit small, A, B, C, D. Suppose only single feeder I am taking care of. So in first step it will be 80, this is coming under first step. What will be second step? This will be coming under second step. What will be third step? 100% of the line, AB. This was your B, huh? This was your B. And this is your original buses. These are your original buses. So what will be third step? 100%, then 120% of this one. Somewhere here it will be third step. It will cover up to this much. Only for one relay, that is this relay. For AB relay only I am taking. AB relay can operate in 3 steps. So you can put 3 different relay for first set. First we will put 3 different. For first step setting we will give 1, second step setting we will give second one, and third step. And there is ultimately another one, that is FD, which will be 250%. Up to this much is your FD. The FD setting will be up to this much. Now somewhere if there is any fault, then who will be going to sense the first? Because FD is instantaneous. So all the relays will sense and all the relays will close its contact. That's it. Now we have given some intentional time delay. I will show you. First you think that if there is any fault, all relay will sense it. Then obviously if it is there, then step 1 will not sense. If it is here, then all will sense. If it is here, then obviously step 3 will only sense. Step 1, step 2 will not sense, because in that case RAB is not your primary. It will come under step 1 of RBC. So if you see, if there is any fault, the first guy who will sense it is FD, because it can see far distance away, 250%. So it will immediately close its contact. So this is shorted. Now what will happen if the fault is in zone 1, that is in the first section, then Z1 also close its contact. So the line is closed So trip, this will give trip command. And this is actually timer circuit. Again, it is not written, you can write it down. This is timer circuit. So once FD is shorted, this timer circuit is activated. Once it gets shorted, once FD senses something, your fault detector interceptors sense something, it immediately sends signal to the timer circuit, and timer circuit is already on, and it will send two signals, one after T1 second, suppose one after 5 seconds, T1 is 5 seconds, and T2 is another 5 seconds. It is hypothetically. So it will send a signal after 5 seconds, and it will again send a signal after another 5 seconds, that is after 10 seconds. So suppose it is in the common zone between Z2, suppose it was in the Z1, so it is in the first section, that is 80 to 90. So Z1 will also send, Z2 will also send, it will also close, Z3 will also close, because it can sense by all the three relays, because it is in the first section, because common for all three. But the line will be shorted by this path, because T2 and T3, these time signals, or it will be T1 and T2. So T1 and T2, these are not still closed, because it will come after 5 seconds, it will close, then after 5 seconds it is closed. So till now it is not closed. So immediately if Z1 is closed, this line is closed. So once trips, then everything will get to its reset value, FD will go to reset value, timer will get to reset value, then there will be no need for T1, T2 time interval. Now suppose it is not in step 1, suppose it is in step 2, so this is on, so this will not trip because it is not in step 1, it is in common zone, that is step 2 and step 3. The common zone means between 120%, between 150%, 150%. So both these will sense Z2, Z3, but Z3 cannot operate because it is given 10-second delay. So once FD is operated, this is activated. So it will wait for step 1, because that zone can come under step 1 of any other relay. If that trips, then it's okay. If doesn't trip, then after 5-second time, T1 will give command. So it will be shorted now. So the path will be now here. So fault will be cleared. So similarly, you can see for if it is in third step, then no, Z1, Z2 will not feel it, only Z3 will feel it, but it will not trip because it will need this should be on, T1 and T2 should be on, but T2 is not on until 10 seconds, because we have given 10 seconds. Hypothetically I am saying. So it will wait, it can come under some others, step 1, step 2, some others relay, so it will wait for that relay to trip. If it doesn't, then T2 will trip. So this is the idea how it works. So this is given. FD detects the fault within its reads and initiates a timer circuit which issues two time signals, T1 and T2, after T1 second and T2 second. If the fault is in step 1, then how the path will be closed? It will be closed through FD and Z1. These contacts are NO. NO means normally open. So if it is if it senses, then it closes its contact. Then it becomes NC, and NC means normally closed. Then it becomes closed. Normally it is open. That's why NO contact. And then circuit breaker trips, after which FD, Z1, your timer circuit, all will be reset. Now if the fault is in step 2, then what will be the path? Then FD, Z2 and T1. This will be the path. You can see that path I have already explained. After which it will be reset. Similar operation for step 3. Now what is the impedance seen by distance relay? It is setting is given ZL, okay, but it is not sensing ZL, because voltage is also you are reducing, current is also you are reducing. You are not actually sensing the actual voltage and current. You are reducing it by using CTPT. So what is the relay sensing? Relay sensing relay voltage by relay current. What is relay voltage? Actual voltage by PT ratio. By what ratio you are dividing? What is relay current? Actual current divided by CT ratio. So it is divide. So it will be, if you take product, it will reverse. So ultimately it will be CT ratio by PT ratio into ZL. You remember this formula. A very nice formula to remember. So actual line impedance is ZL, but relay is not sensing your ZL. It is sensing by a factor, reduced factor, CT by PT. So you can see this one. So this is it. It may be reduced, it may be increased. It depends on the ratio also. So this is the actual Z that the relay is sensing. Now how this 3-step protection is implemented? By using Moho relay, you can say. So you can see this is the set. This is the first step protection Z1, because its setting is 80%. That's why it is a small circle. So it is Z2, second one. It is third step, and it is the fourth step. That is your FD. So you can see first one is 80 to 90. Next one was 150. Sorry, it is 150, it is 80, 90. 150 is not exactly 150, I am saying 150 of the shortest line. And it is 220, not exactly 220, 100 and 120 of the next longest line. It is 250 but not exactly 250, 100 and 150 of the longest line. So by using a more relay, you can see. Now how to, for all three step protection, how many relays now you will need? How many units you need? So you can see in my distance relay implementation, we need 6 units. Relay 1, relay 2, I have drawn a table. 6 relay were required for a complete all 11 fault protection. So 6 for step 1, 6 for step 2, 6 for step 3. So you need 18 units to complete protection step 1, step 2. However, it can be reduced by using other techniques for economic ideas, but we'll leave it here only. So next day we'll start transformer protection, because distance protection is over now. If you liked the video, then press the like button and please give your valuable comments in the comment section.